Heat transfer test questions number 5. Question 1. When the layers of a composite wall are in series and the thermal resistance of every individual layer is given, then the total thermal resistance of the composite wall is given by A. Substantiating lower value thermal resistance from higher value thermal resistance. B. Adding both the thermal resistances. C. Multiplying both the thermal resistances. D. None of the
Answer: adding both the thermal resistances.
Question 2. A hollow cylinder of length of 1 meter, inner radius ρ 0.01 meters and outer radius ρ 0.05 meters has a thermal conductivity K20 W, mK. The inside surface temperature is at 500 K. What is the outside surf K? What is the outside surface temperature of the cylinder when the rate of radial heat transfer is 3.13 kilowatts? A. 400 K. B. 360 K. C. 460 K. D. Inside.
Answer: 460 K.
Question 3. As the radius increases in hollow cylinder, the temperature A. also increases. B. decreases. C. it depends upon the direction of heat flow. D. unpredictable.
Answer: it depends upon the direction of heat flow.
Question 4. What is the effect of change in outer radius of the hollow cylinder on the thermal resistance of conduction? A. The thermal resistance of conduction increases with increase in outer radius of the hollow cylinder. B. The thermal resistance of conduction decreases with increase in outer radius of the hollow cylinder. C. The thermal resistance of conduction remains same with change in outer radius of the hollow cylinder. D. unpredictable.
Answer: the thermal resistance of conduction increases with increase in outer radius of the hollow cylinder.
Question 5. What is the effect of change in outer radius of the hollow cylinder on the thermal resistance of convection? A. The thermal resistance of convection increases with increase in outer radius of the hollow cylinder. B. The thermal resistance of convection decreases with increase in outer radius of the hollow cylinder. C. The thermal resistance of convection remains same with change in outer radius of the hollow cylinder. D. unpredictable.
Answer: the thermal resistance of convection decreases with increase in outer radius of the hollow cylinder.
Question 6. Consider a plane wall of area A, having a layer of insulation on it. What will happen to the thermal resistance for convection of wall if the thickness of the insulation is increased? A. The thermal resistance for convection increases with increase in thickness of insulation. B. The thermal resistance for convection decreases with increase in thickness of insulation. C. The thermal resistance for convection remains same with increase in thickness of insulation. D. unpredictable.
Answer: the thermal resistance for convection remains same with increase in thickness of insulation.
Question 7. Which of the following assumptions are correct to obtain an analytical solution for the problem on laminar boundary layer of fluid on flat plate? A. The fluid is incompressible. B. The fluid is in steady state. C. The is not affected by fluid flow. D. All of the above.
Answer: all of the above.
Question 8. Change in momentum is A. The result of powers acting on the surface of the control volume. B. The result of works acting on the surface of the control volume. C. The result of forces acting on the surface of the control volume. D. None of the above.
Answer: the result of forces acting on the surface of the control volume.
Question 9. Assume a turbulent flow of a fluid on a flat plate. A very thin region near the plate surface is called as A. Laminar buffer layer. B. Laminar sublayer. C. Laminar turbulent layer. D. None of the above.
Answer: laminar sublayer.
Question 10. The layer above the laminar sublayer with some turbulence and still having importance of viscous action is called as A. Sublayer. B. Turbulent layer. C. Buffer layer. D. None of the above.
Answer: buffer layer.
Question 11. The layer through which the momentum and energy transfer take place via the movement of macroscopic lumps of matter from one region to another is called as A. The laminar sublayer. B. The buffer layer. C. The turbulent layer. D. None of the above.
Answer: the turbulent layer.
Question 12. What is used instead of in turbulent boundary layer condition? A. Eddy diffusivity for momentum. B. Eddy diffusivity for force. C. Eddy diffusivity for heat. D. None of the above.
Answer: eddy diffusivity for momentum.
Question 13. The eddy properties are used in turbulent boundary layer condition because A. The eddy properties may be small compared to molecular properties. B. The eddy properties may be large compared to molecular properties. C. The eddy properties may be small or may be large compared to molecular properties, but never equals to molecular properties. D. None of the above.
Answer: the eddy properties may be large compared to molecular properties.
Question 14. Generally, natural convection occurs due to A. Change in velocity of a fluid. B. Change in density of a fluid. C. Change in molecular structure of a fluid. D. None of the above.
Answer: change in density of a fluid.
Question 15. The rate of radiant flux between two black bodies is analogous to A. Resistance in electrical system. B. Voltage in electrical system. C. Current in electrical system. D. None of the above.
Answer: current in electrical system.
Question 16. How does the gray body differ from the black body? A. All the incident radiation is not absorbed completely by gray body. B. The emissivity of the gray body is less than unity. C. The absorptivity of the gray body is less than unity. D. All of the above.
Answer: all of the above.
Question 17. How are the real bodies in terms of diffuseness? A. Real bodies are perfectly diffuse. B. Real bodies are not perfectly diffuse.
Answer: real bodies are not perfectly diffuse.
Question 18. For the diffuse surfaces. A. The intensity of emitted radiation is constant and depends upon the direction. B. The intensity of emitted radiation is not constant and depends upon the direction. C. The intensity of emitted radiation is constant and does not depend upon the direction. D. None of the above.
Answer: the intensity of emitted radiation is constant and does not depend upon the direction.
Question 19. What is irradiation G? A. The total radiation incident upon a surface per unit time per unit surface area. B. The total radiation leaving a surface per unit time per unit surface area. C. The net radiation exchanging between two surfaces per unit time per unit surface area. D. None of the above.
Answer: the total radiation incident upon the surface per unit time per unit surface area.
Question 20. Which of the following is, our example, S of heat exchanger? A. Feed water heater in which a stream of steam is directly mixed with cold water and the mixture leaves at uniform temperature. B. Feed water heater in which a stream of steam and cold water are not mixed and separated by partition through which heat flows. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 21. Which of the following phases of designing of heat exchangers does designer consider corrosive nature of the fluid in? A. The thermal analysis. B. The mechanical design. C. The design for manufacture. D. None of the above.
Answer: the mechanical design.
Question 22. Which of the following is not a type of heat exchanger? A. Recuperator. B. Regenerator. C. Mixer. D. None of the above.
Answer: none of the above.
Question 23. The two fluids are not mixed and kept separated as they both flow through heat exchanger in A. Transfer type heat exchanger or recuperator. B. Storage type heat exchanger or regenerator. C. Direct contact type heat exchanger or mixer. D. None of the above.
Answer: transfer type heat exchanger or recuperator.
Question 24. Which of the following is, our example, S of direct contact type heat exchanger? A. Jet condenser. B. Desuperheater. C. Cooling tower. D. All of the above.
Answer: all of the above.
Question 25. What is the reason behind the fact that the thermal resistance of hollow cylinder for convection decreases with increase in the thickness of the insulation? A. Volume of insulating material increases and it transfer less heat energy. B. Increase in surface area of the cylinder leads to less convective heat transfer. C. Increase in surface area of the cylinder leads to more convective heat transfer. D. None of the above.
Answer: increase in surface area of the cylinder leads to more convective heat transfer.
Question 26. What is the critical thickness of insulation for hollow cylinder? A. A thickness of insulation at which heat transfer rate from cylinder is minimum. B. A thickness of insulation at which heat transfer rate from cylinder is maximum. C. A thickness of insulation at which heat transfer from cylinder does not change with change in outside temperature. D. None of the above.
Answer: a thickness of insulation at which heat transfer rate from cylinder is maximum.
Question 27. When the thickness of an insulation is greater than the critical thickness of insulation, then the heat transfer rate of insulated pipe A. will be more than the heat transfer rate from the same pipe without insulation. B. will be less than the heat transfer rate from the same pipe without insulation. C. will become equal to the heat transfer rate from the same pipe without insulation. D. None of the above.
Answer: will be less than the heat transfer rate from the same pipe without insulation.
Question 28. When the thickness of insulation is less than the critical thickness of the insulation, then the heat transfer rate of insulated pipe A. will be more than the heat transfer rate from the same pipe without insulation. B. will be less than the heat transfer rate from the same pipe without insulation. C. will become equal to the heat transfer rate from the same pipe without insulation. D. None of the above.
Answer: will be more than the heat transfer rate from the same pipe without insulation/voice.
Question 29. What is the advantage of using the spherical vessel to store fluids at low temperature? A. Heat transfer in sphere is restricted in all direction by insulation. B. Sphere has the smallest volume per unit surface area. C. Sphere has the largest volume per unit surface area. D. None of the above.
Answer: sphere has the largest volume per unit surface area.
Question 30. At the critical radius of insulation of a hollow sphere, the heat transfer will be A. minimum. B. maximum. C. does not change. D. unpredictable.
Answer: maximum.
Question 31. The buoyancy forces which give rise to the natural convection are called as A. convection forces. B. fluid forces. C. body forces. D. None of the above.
Answer: body forces.
Question 32. The intensity of mixing of fluid in natural convection is A. More than the intensity of mixing of fluid in forced convection. B. Less than the intensity of mixing of fluid in forced convection. C. Equal to the intensity of mixing of fluid in forced convection. D. Unpredictable.
Answer: less than the intensity of mixing of fluid in forced convection.
Question 33. What is the relation between convection heat transfer coefficients of natural convection and forced convection? A. Convection heat transfer coefficient of natural convection is lower than the convection heat transfer coefficient of forced convection. B. Convection heat transfer coefficient of natural convection is more than the convection heat transfer coefficient of forced convection. C. Convection heat transfer coefficients in both natural and forced convection are the same for same system. D. Unpredictable.
Answer: convection heat transfer coefficient of natural convection is lower than the convection heat transfer coefficient of forced convection.
Question 34. Below figure shows a natural convection heat transfer on a vertical flat plate surrounded by a fluid. What is the relation between the upward velocity of the fluid and the distance from the bottom of the plate, when plate is hotter than fluid? A. As the distance from the bottom of the plate increases, the upward velocity of the fluid near the plate surface decreases. B. As the distance from the bottom of the plate increases, the upward velocity of the fluid near the plate surface increases. C. The upward velocity of the fluid near the plate surface is same all over the plate. D. Unpredictable.
Answer: as the distance from the bottom of the plate increases, the upward velocity of the fluid near the plate surface increases.
Question 35. Assume a natural convection heat transfer on a vertical flat plate surrounded by a fluid. Where will be the fully developed turbulent layer of fluid established, if the plate is hotter than the fluid? A. At the bottom of the plate. B. At the middle of the plate. At the middle of the plate. C. At the top of the plate. D.
Answer: at the top of the plate.
Question 36. Below figure shows a natural convection heat transfer on a horizontal flat plate and fluid is above it. Which condition satisfies the figure below? A. Plate temperature is lower than the fluid temperature. B. Plate temperature is higher than the fluid temperature. C. Plate temperature is equal to the fluid temperature. D. Unpredictable.
Answer: plate temperature is higher than the fluid temperature.
Question 37. Assume fluid flowing in a tube forcefully. The velocity boundary layer develops along the tube. Thickness of this boundary layer increases in the flow direction until the boundary layer reaches the tube center. This region from the tube inlet to the point at which the boundary layers merge at the center line is called as A. Laminar entry region. B. Hydraulic entry region. C. Hydrostatic entry region. D. Hydrodynamic entry.
Answer: hydrodynamic entry region.
Question 38. What is hydrodynamically developed region in fluid flowing inside a pipe? A. A region where velocity profile of the fluid is partially developed. B. A region where velocity profile of the fluid is fully developed. C. A region where velocity profile of the fluid changes according to the distance. D. None of the above.
Answer: a region where velocity profile of the fluid is fully developed.
Question 39. What is the ratio of the buoyancy force to the viscous force acting on a fluid called? A. Prandtl number PR. B. Reynolds number Re. C. Nusselt number Nu. D. Grashof number GR.
Answer: Grashof number GR.
Question 40. In natural convection, the Nusselt number Nu depends on A. PR and Re. B. GR and Re. C. GR and PR. D. None of the above.
Answer: GR and PR.
Question 41. The total radiation leaving a surface per unit time per unit surface area is called as A. Radiosity. B. Irradiosity. C. Irradiation. D. None of the above.
Answer: Radiosity.
Question 42. Radiosity J is the sum of radiation A. Emitted, reflected and absorbed. B. Emitted, reflected and transmitted. C. Transmitted, reflected and absorbed. D. None of the above.
Answer: emitted, reflected and transmitted.
Question 43. Radiation shields are used A. To increase radiant heat transfer. B. To decrease radiant heat transfer. C. To maintain radiant heat transfer constant. D. None of the above.
Answer: to decrease radiant heat transfer.
Question 44. Which surface can be best described as a radiation shield? A. The surface which has very high absorptivity. B. The surface which has very high transmissivity. C. The surface which has very high reflectivity. D. D. None of the above.
Answer: the surface which has very high reflectivity.
Question 45. Which object can be used as a radiation shield? A. Polished transparent glass. B. Mirror. C. Rubber. D. All of the above.
Answer: mirror.
Question 46. Which of the following gases are not capable to emit and to absorb radiant heat energy? A. Nitrogen N2. B. Water vapor H2O. C. Carbon monoxide CO. D. D. All of the above.
Answer: nitrogen N2.
Question 47. Which of the following gases are capable to emit and to absorb radiant heat energy? A. Carbon dioxide CO2. B. Sulfur dioxide SO2. C. Ammonia NH3. H3. D. All of the above.
Answer: all of the above.
Question 48. Which among the following factors are taken into account in calculation of radiation emitted or absorbed by a gas layer? A. Thickness of the gas layer. B. Shape of the gas enclosure. C. Pressure in gas enclosure. D. All of the above.
Answer: all of the above.
Question 49. How is the incident radiation absorbed by a gas layer? A. A gas layer absorbs incident radiation slowly. B. A gas layer absorbs incident radiation rapidly. C. Doesn't matter. D. Unpredictable.
Answer: a gas layer absorbs incident radiation slowly.
Question 50. What are the compact heat exchangers? A. The heat exchangers having small surface area per unit volume. B. The heat exchangers having large surface area per unit volume. C. The heat exchangers having small surface area per unit weight. D. The heat exchangers having large surface area per unit weight.
Answer: the heat exchangers having large surface area per unit volume.
Question 51. Which of the following can be considered as more compact efficient heat exchanger? A. Car radiators. B. Stirling engine regenerator. C. Ceramic regenerator in gas turbine. D. None of the above.
Answer: Stirling engine regenerator.
Question 52. The compact heat exchangers are commonly used in A. Gas-to-gas heat transfer. B. Gas-to-liquid heat transfer. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 53. Usually, the flow arrangement of two fluids in compact heat exchangers is A. Parallel flow. B. Counterflow. C. Cross flow. D. None of the above.
Answer: cross flow.
Question 54. What is effectiveness of fin? A. The ratio of actual heat transferred from fin area to the heat which would be transferred if entire fin area was at base temperature. B. The heat which would be transferred if entire fin area was at base temperature to the ratio of actual heat transferred from fin area. C. The heat which would be transferred if entire fin area was at minimum temperature to the ratio of actual heat transferred from fin area. D. The ratio of actual heat transferred from fin area to the heat which would be transferred if entire fin area was at minimum temperature.
Answer: the ratio of actual heat transferred from fin area to the heat which would be transferred if entire fin area was at base temperature.
Question 55. What is the effect of thermal conductivity K on fin effectiveness? A. Fin is effective for smaller value of thermal conductivity K. B. Fin is effective for larger value of thermal conductivity K. C. Thermal conductivity K does not affect the fin effectiveness. D. Cannot say.
Answer: fin is effective for larger value of thermal conductivity K.
Question 56. What is the effect of convective heat transfer coefficient H on fin effectiveness? A. Fin is effective if the value of convective heat transfer coefficient H is small. B. Fin is effective if the value of convective heat transfer coefficient H is large. C. Fin effectiveness does not affected by the value of convective heat transfer coefficient H. D. None of the above.
Answer: fin is effective if the value of convective heat transfer coefficient H is small.
Question 57. Which medium of surrounding is better for fin effectiveness? A. Gas medium. B. Liquid medium. C. Fins have same effectiveness in both the gas and liquid mediums. D. None of the above.
Answer: gas medium.
Question 58. For effective working of fins, the thickness of the fines should be A. Large. B. Small. C. Thickness of fin does not affect the fin effectiveness. D. Unpredictable.
Answer: small.
Question 59. Aluminum is used as a fin material because A. It has higher convection heat transfer coefficient. B. It has higher thermal conductivity. C. It has lower convection heat transfer coefficient. D. It has lower thermal conductivity.
Answer: it has higher thermal conductivity.
Question 60. Which of the following arrangements of fins is more effective for the same base area? 1. Large number of closely spaced fins. 2. Small number of thick fins. A. Arrangement 1. B. Arrangement 2. C. Both the arrangements 1 and 2 are similarly effective. D. Unpredictable.
Answer: arrangement 1.
Question 61. When does the general heat conduction equation which gives the temperature distribution and conduction heat flow in an isotropic solid reduce to Laplace equation? A. If the body or element is in unsteady state with heat generation. B. If the body or element is in steady state with heat generation. C. If the body or element is in unsteady state with no heat generation. D. If the body or element is in steady state with no heat generation.
Answer: if the body or element is in steady state with no heat generation.
Question 62. Generally the external thermal resistance between the surface of the body and the environment is A. Less than the internal conduction resistance in the body. B. More than the internal conduction resistance in the body. C. Same as the internal conduction resistance in the body. D. None of the above.
Answer: more than the internal conduction resistance in the body.
Question 63. Suppose that a hot metal ball is immersed in cold water, then temperature distribution in the body depends upon A. Thermal conductivity of the body. B. Convective heat transfer from the body surface to water. C. Both A, C. Both A and B. D. None of the above.
Answer: both A and B.
Question 64. Suppose that a hot metal ball is suddenly immersed in cold water. What is the condition for the ball to maintain it at a uniform temperature? A. The conduction resistance in a ball should be very large compared to the convection resistance for heat transfer from surface of ball to water. B. The conduction resistance in a ball should be very small compared to the convection resistance for heat transfer from surface of ball to water. C. The conduction resistance in a ball should be equal to the convection resistance for heat transfer from surface of ball to water. D. Cannot say.
Answer: the conduction resistance in a ball should be very small compared to the convection resistance for heat transfer from surface of ball to water.
Question 65. What is lumped heat capacity analysis? A. The analysis of a system in which it is assumed to be at no uniform temperature. B. The analysis of a system in which it is assumed to be at uniform temperature. C. The analysis of a system in which it is assumed to be at either uniform or no uniform temperature. D. None of the above.
Answer: the analysis of a system in which it is assumed to be at uniform temperature.
Question 66. The Biot number or Biot modulus is given by A. The ratio of external convection resistance to the internal conduction resistance. B. The ratio of internal conduction resistance to the external convection resistance. C. Multiplying internal conduction resistance and external convection resistance. D. None of the above.
Answer: the ratio of internal conduction resistance to the external convection resistance.
Question 67. The cooling of a metal ball of volume V, in large quantity of fluid is analogous to A. Discharging of battery in an electric system. B. Discharging of capacitor in an electric system. C. Generation of heat in resistor in an electrical system. D. None of the above.
Answer: discharging of capacitor in an electric system.
Question 68. The Grashof number in natural convection plays same role as A. Prandtl number PR in forced convection. B. Reynolds number Re in forced convection. C. Nusselt number Nu in forced convection. D. Action. D. None of the above.
Answer: Reynolds number reinforced convection.
Question 69. When is the arithmetic mean temperature difference of heat exchanger used instead of LMTD? A. When the temperature profiles of two fluids of heat exchanger are sloping downward with curve. B. When the temperature profiles of two fluids of heat exchanger are sloping upward with curve. C. When the temperature profiles of two fluids of heat exchanger are straight. D. None of the above.
Answer: when the temperature profiles of two fluids of heat exchanger are straight.
Question 70. How can the arithmetic mean temperature difference and LMTD of a same heat exchanger be compared? A. The arithmetic mean temperature difference is less than LMTD of a same heat exchanger. B. The arithmetic mean temperature difference is more than LMTD of a same heat exchanger. C. The arithmetic mean temperature difference and LMTD of a same heat exchanger are equal. D. None of the above.
Answer: the arithmetic mean temperature difference is more than LMTD of a same heat exchanger.
Question 71. In parallel flow heat exchangers. A. The exit temperature of hot fluid is always equal to the exit temperature of cold fluid. B. The exit temperature of hot fluid is always less than the exit temperature of cold fluid. C. The exit temperature of hot fluid is always more than the exit temperature of cold fluid. D. We cannot predict comparison between exit temperatures of hot fluid and cold fluid.
Answer: the exit temperature of hot fluid is always more than the exit temperature of cold fluid.
Thanks for watching. Please comment, like and share.